So moving on today, we're going to be dealing with greatest common factor. Okay, we're going to worry about this goal tomorrow, but today we're going to be focused on greatest common factor, also known as GCF. Okay, does anybody know what greatest common factor means? If we have two numbers, what does it mean by us trying to find the greatest common factor?
Well, they can both multiply by 2.
Close. Opposite. Yeah.
What number that they can multiply by?
Right. Right. You're both on the right track. It's a number that can go into both of them. The highest possible number that goes into both numbers that we're looking at. Okay? So examples I want to look at first, 10 and 12. Looking at 10 and 12, is there a number that goes into both of those?
Yes. Yeah.
What?
120. You say 100?
2. We want a number that goes into both of them, not one that they multiply to.
Oh.
So a number that goes into both of them is 2. Can we go higher? Is there a number higher than 2? No. 2 is the highest we can go. So by looking at that, we can just guess 2, right? And we are pretty confident in that because the numbers are lower, right? A way you can do that if you did not know it was 2 right off the bat is make little factor trees. Okay, so start with 10. What are 2 numbers that multiply to give you 10? 2 and 5, right? Can I break apart 2 and 5? Like, is there 2 numbers that go together to multiply to get you 2? No. Are there numbers that multiply together to get you 5? Other than itself and 1. There isn't, right? So the only factors of 10 are 2 and 5. Looking at 12, what are factors of 12? 6 and 2. Okay, can I break apart 6? What are 2 factors that go into 6? 3 and 2. Okay, can I break apart any of these ending numbers? No, that's the farthest all of them can go, right? So your factor tree is complete. What were the numbers we ended up with on 10? 2 and 5. What were the numbers we ended up with on 12?
3,
2, 2, and 3, right? I like to write them in numerical order, and I'll explain why right now, okay? Once we get to this point, the reason I put them in list form, like I did, we want to find pairs that match, okay? 10 has 2. Does 12 have 2? Yes. So those match. That's a part of my final answer, okay? Are there any other pairs between the 2? No. So our answer is 2, which we got before, right? Okay. If we had bigger numbers, 18 and 24, is it easier to look at those, or is it as easy to look at those and say what the answer is? Or off the bat? No. Could we think about it and guess and check? Okay. It is 6. The factor trees eliminate the possibility of guess and check. Okay, it makes the guess and check process quicker. Okay, so then it's not just thinking about it, you're actually figuring it out. Okay, so let's try the factor trees. Start with 18. What are 2 numbers that multiply to give you 18? 6 and 3. Okay, can I break apart 6?
Yep.
To what?
3 and 2.
3 and 2. Can I do any more of those? Do anything else to those? No, right? I can't break apart 3 and I can't break apart 2. So that's it for 18. What about 24?
12.
12 and 2? Could I have also done 8 and 3? Yes, it does not matter. You will end up getting the same thing at the end. Okay? What about 12? 6 and 2. And then 6 we said was 3 and 2. Can we go any farther with any of our ending factors? No. Okay, so 18, what did we end up with 18? Yep, 2, 3, and 3. And then 24, what were our ending numbers? Yes. Everyone okay up to this point?
Yep.
Okay. What do we want to do from here? Remember?
You find the same.
Find pairs, right? What pairs do we have?
2.
2 is a pair, so I add that to the end.
3.
And 3 is a pair. Do we have any others?
Well, on the bottom there's 2.
But between the 2, are there any more matches? No. So now we have 2 times 3. What does that give us? 6. And is that what someone said before? Yep. So this eliminates the whole guess and check process. Okay? When we get more comfortable determining greatest common factors, we don't even need to worry about the factor trees. okay? But if you need to and you're not sure, go do the factor tree, okay? Okay. What's going to happen if we get x's involved? What changes? Does the greatest common factor of the numbers change? No. Okay? The only thing that is added is the matching variable that they have. Okay? So looking at 4 and 12, can you tell me a number that goes into both of those? 2 does. Can we go higher though? 4. 4 is the highest, so 4 is our number. And then do they have anything else in common? X, right? So 4x would be our common factor in that case. Okay? Looking at B, is it as easy to look at 18 and 20 and find a common number? It is 2. Okay? What can we do if we did not know for guess and check purposes?
I don't know.
Factor trees, right? Okay? But seeing it, we see 2. And then what else do they have in common? The A. Can we put the B on the greatest common factor? No, why not? It's not on both, right? Good. Okay, go ahead and try just A. Just do A first. What's your question?
Beat up B and just kick it out.
Yes, because it only wants the greatest common factor of both. Okay, so try A, do A first, and then we'll do A together. Okay? Okay, on A, can we look at 28 and 48 and automatically know a number right off the bat?
I did.
Some of us can, but if we can't, we go to what? Factor tree, okay? Factor tree, I'm going to start with 28. I always start with the smallest number for some reason, but it doesn't matter, okay? 28, what's a number that goes into 28?
4.
7 and 4, right? Can we break apart either of those? 4, 2, and 2. Okay, can we go any farther with any of those? No, so now we move on to 48.
12, wait. I just said 8 and 4.
12 and 6.
8 and 4 would be 32. What'd you say?
12 and 6.
4 and 12. Can we break apart 4? 2, 2. What about 6? You can do 4, 3. What about 4? 2, 2. Can we go into any more of those? No. Okay, what do we do from this point? Line them up, right? Make your list. 28, what were the ending numbers we had? Yep, 2, 2, and 7 was 28. What about 48? What were our ending numbers? How many 2s we got? 4 and then 1, 3. Okay, is everyone okay up to the part where we make the list? Okay, what do we look at now? Common numbers, right? Do they both have 2? Yep, so 2 is in our final answer. What else we got?
2.
Another 2?
And that's all.
That's it, right? 2 times 2?
4.
What are we missing?
X.
X, right? They both have X in common. So if we multiply those together, we get 4X. You got it. Nice job. Go ahead and try B now. Okay, I see some of us aren't doing factor trees. That's okay, but we got to make sure we have our correct answer, okay? So if you did not do a factor tree, let's check it. 16, what are numbers I can break apart 16?
8 and 2.
I heard 8 and 2. I also heard 4 and 4. That's also correct. Okay, what about 8?
Oh, you go.
4 and 2. What about 4?
2 and 2.
2 and 2. Okay, if you started with different numbers up here, if you started with 4 and 4, you would still end up getting the same numbers. Okay? What about 40?
8 and 5.
8 and 5? What about 8?
4 and
4 and 2? And then, can any more of those get?
4.
4 is 2 and 2. Is everyone okay with the factor trees? Okay, next we make what? List, yep. What were our ending numbers in 16? 4 of them? And then what about 40? 2, 2, 2, 5. Good. What else are we forgetting? The S, and then 40 had S and T. Good. Okay. From here, what's our last step we got to do?
The combined.
Find common pairs. Yep. What's a common pair? 2, 2, 2, S. Anything else?
Nope.
Nope. So now what do we do with these four terms? Yep. 2 times 2 times 2 times S. 8S. Okay, I saw some of us had 4 as our final answer. We got to find the highest number value. Okay? Any questions on greatest common factor? No? Okay, tomorrow we're going to get into factoring, knowing the greatest common factors, okay? But today we are going to practice a lot of greatest common factors.